Okay, so this is problem, the last problem on the assignment from yesterday. Anyways, you were given 2 points, and you were asked to do a couple things like find the distance, find the midpoint, and then find the slope, and so on. So we had some troubles with finding slope. So I just wanted to remind you of how to do that. So remember, we have x, y points. Points are in the form x, comma, y. And you can call either or the first point. It doesn't matter as long as you stay consistent. So I'm going to call this my first point. Now remember, that little mini 1 doesn't mean anything besides specifying it's the first point. And then I have, this is my second point. That little mini 2 just means that's what I'm calling my second point. Now to find the slope of a line, you can use this formula. You'll take your y2 minus your y1 all over x2 minus x1, just plugging it in. So y2 is this value, which is 0. So 0 minus y1, which is 2, and then all over x2. So x2, which is negative 21, minus x1, which was 3. So minus 3. Now we'll just simplify it. So 0 minus 2 on top is negative 2, and on bottom we have negative 21 minus 3. Very carefully, that's actually negative 24. Now looking at negative 2 over negative 24, we have a negative divided by a negative, and we know that that becomes positive. Any negative divided by a negative becomes positive. And then 2 over 24 simplifies to be, well, 2 divided by 2 and becomes 1. 24 divided by 2 and becomes 12. So we get 112. Or you could have typed it into your calculator. You could have done negative 2 divided by negative 24 in your calculator, and then changed it back into a fraction, and you would have got 112. So our line has the form y is equal to mx plus b, where m is the slope, so we just found the slope. Y is equal to 112x plus b. Now you want to find the y-intercept. If you wanted to keep going, we're done. We found the slope, but if you wanted to keep going and find the line, because that was the next question, you could find b by plugging in x and y. You can use either point A up here or point B. It doesn't matter. So I'm just going to go ahead and use x, y. I'm going to use this is x, this is y, and plug it in down here to finish, and then I can solve for b. Okay, so now we're learning the new thing today. We're going to be factoring when you have the sum or difference of two perfect cubes. So we're going to take this polynomial that has two terms, and each term is going to be a perfect cube. Now, what a perfect cube means is if you take the cube root of it, so for example, the cube root of 8 is equal to 2, and it comes out to be a whole number with no decimals. And if we take so I guess before I go on, understand that 8 is a perfect cube because 2 comes out to be a whole number. And once again, 2 cubed is equal to 8. That's why the cube root of 8 is equal to 2. So if it comes out to be a whole number, we know it's a perfect cube. So if we take the cube root of x cubed, then our root cancels out with our power and we just get x. So x comes out evenly. So x is also a perfect cube. It doesn't have any decimals or fractions. All right, so now we're going to be taking these polynomials and we're going to have the sum of two perfect cubes. So x cubed is a perfect cube, and 8 is a perfect cube. So sum of two perfect cubes would be x cubed plus 8. And an example of the difference of two perfect cubes, well, we know x cubed is a perfect cube minus, so difference of two perfect cubes, and 8 is a perfect cube. So this is the difference of two perfect cubes, the sum of two perfect cubes. So that's what they mean by that. Well, there's a trick to use when trying to factor the sum or difference of two perfect cubes. So if you have a perfect cubed a cubed and b cubed, you can find a, the front term, by taking the cube root of a cubed, and that will give you a. Now, you can take the cube root of b cubed, and you get b. So our front term is going to be a, and our back term is going to be b. And what this factors to be is this. So we have this will factor to b, so this is going to factor to be a minus b in parentheses times a squared plus ab plus b squared. Okay, now looking at this one, well, before I go through it, actually, I want to go through my song. There's a little trick you can use to help you memorize this so that hopefully the memorization's a little bit easier. So you were able to see hopefully how I found my front and my back term. I took the cube root of the front, the cube root of the back, and I get my front and back, okay? So now what you're going to do is you're going to go ahead and say, okay, I know I'm going to put in parentheses. Now you've just got to memorize this first part here. You're going to put your parentheses and you're going to write your front term, which would be A, and your back term, which would be B. Then the sign in between will always be what you started with. So notice my starting sign was negative, so this is going to be negative. Now we're going to go through and fill in the next part of our parentheses here. So then the song goes. Now this is where the song helps you remember what goes where and how to do this. It's just a quick way of remembering it. So the song goes, the front with the front, and the front with the back, then the back with the back. So let's start with the first of our song, which says the front with the front. So the front with the front. Well, the front with the front would be a times a, which is a squared. Now you'll do the front with the back. So the front with the back. So a times b is a b. And then the back with the back. So b times b is b squared. All right, so now I close my parentheses. Now let's go and fill in all the signs. So this is the process you'll take. If this was negative, this sign out here is always going to be the opposite of what you started with than this first one. So if this is negative, this will be positive because it's always the opposite. And then this end one here is always going to be positive no matter what. So this is a quick way of remembering how to fill this in. Now once again, that was the difference of two perfect cubes. Let's look at our example of the sum of two perfect cubes. It's sum because it's plus. So we know to find our front term, we'll take the cube root of the front, which is just a. The cube root of a cubes a. There's our front. And our back will be the cube root of b cubed. So our back will be b. And then we'll go through and do our little process here. So we know in parentheses, and I already have it written, but I'm just going through the process so that you know how to fill this in. You put your parentheses, you do the front term and then the back term. Then you look at the sign that you originally started with, and it was plus. So the sign inside must be plus. Now you continue to fill it in using your sum. So we'll do the front with the front. So the front with the front. So a times a is a squared. And then we'll do the front with the back. So the front with the back. So that would be a times b, which is ab. And then we'll do the back with the back. So the back with the back. So b times b is b squared. And then we'll go through and fill in our signs. Well, once again, the first starting sign is always what you were given. So since it was plus in the beginning, it's now plus in this first parentheses. Then you go to your second sign and it's always going to be opposite. So since this was plus, this must be negative. And then the sign on the end will always be positive. So that's just a way to help you remember how to fill these things in. So let's do our first example. So it says factor and then solve. So given x cubed minus 64, we want to factor it. Well, we know our little trick. Now notice the reason we're using this trick is because we have two terms and they both are perfect cubes. Otherwise, we wouldn't use this method. So the first thing we'll do is find our front term. So we'll take the cube root of x cubed. You take the cube root of the front term, and you get our root cancels out our power, so we get x. So our front term is x. And then we'll take our back term and take the cube root, not including the sign. Do not include the sign in your cube rooting. So cube root of 64, which is 4. And then we'll go through and do our song, okay? But before we do our song, actually, we have to start out by putting in our parentheses. Then you put in your front term, which is x, and your back term, which is 4. Then to fill in the sign in between, remember you look at the beginning sign what you're given, it was minus, so this is going to be minus. And then this is where our song begins. The front with the front, so x times x, which is x squared. Then the front with the back, so the front with the back. So x times 4 is 4x. Then you'll do the back with the back with the back, so 4 times 4, which is 16. And you'll close your parentheses. Now you need to go through and fill in the signs. Well, if this was negative, the sign directly after that will always be opposite, so this must be plus. And then the sign on the end here is always plus. So we have factored this. Now we can go through and simplify this to actually solve. So what we'll do is we know that by the zero product property rule, we can set each of our factors equal to 0. So I'm going to set x minus 4 equal to 0, and then I'm going to solve for x piece by piece. So I'm going to add 4 to both sides. So x is equal to 4. There's one of my solutions. Now looking at this, we have to set this factor equal to 0. So we have x squared plus 4x plus 16 is equal to 0. Now notice, this is a quadratic equation. So it's a quadratic equation because of that degree 2 right there on the x squared. So we've got to solve quadratics either by factoring, if it's factorable, or the quadratic formula. And I'm going to just use the quadratic formula, and this one happens to not factor. So I'm going to go ahead and use the quadratic formula. Now remember, the quadratic formula always works. So let's do it. A is equal to 1, B is equal to 4, C is equal to 16. So you can keep solving this piece by piece. So the quadratic formula says x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, and that's all over 2 times a. So now let's just plug it in. We get x is equal to the opposite of b, so the opposite of b would be negative 4. So then plus and minus the square root of b squared, so b is 4 squared, minus 4 times a is 1, times c is 16, and that's all over 2 times a, 2 times 1. Okay, let's keep solving this and simplifying it down. So we have x is equal to negative 4 plus or minus the square root. 4 squared is positive 16. And then we have negative 4 times 1 times 16, which is negative 64. So it's minus 64 because it was negative 64. We put the minus. If it would have been positive 64, we would have said plus 64. Because remember, we plugged in this as a negative form into our calculator, so that accounts for the signs. 2 times 1 is 2. So continuing to simplify here, we have x is equal to negative 4 plus or minus the square root. 16 minus 64 is equal to negative 48, and that's all over 2. So this is where we go off to the side and we simplify what was under the root, the square root of negative 48. We've got to break it into its factors. Well, remember, really what we have is the square root of negative 1 times 48. So let's break down 48 into its factors. So 8 times 6 is 48, or 6 times 8, same thing. 6 breaks down into 3 times 2. 8 breaks down into 4 times 2. 4 breaks down into 2 times 2. And now we've broken this down to the prime factors. Now, because it's a square root, we're pulling out groups of 2. So I have 2 2's right there. I can pull out a 2 for those 2 2's. And right there, I can pull out a 2 for those 2 2's. Now, this 3 can't leave the house. It's got to stay. And then I can't forget, when I have the square root of negative 1, I pull out the negative 1 and have an I. So on the outside, I pull out a 2 for those 2 2's, times 2, I pull out a 2 for those 2 2's, and then I pulled out an I for the negative 1, and then left underneath was the 3 here. So we have 4i square roots of 3. Now remember, that was just this piece right here, so I'm going to rewrite it again. We have x is equal to negative 4 plus or minus 4i square roots of 3 all over 2. And don't float on accident. A lot of people are floating this 4 in with this 4, but remember, it's not. It's on the outside after the plus and minus sign, so just don't make that mistake. All right, now I will look and see if all 3 terms divide by something in common, and they all divide by 2. So that divides by 2 and becomes 2. divides by 2 and becomes 2, divides by 2 and becomes 1. So what we have here is x is equal to negative 2 plus or minus 2I square roots of 3 all over 1. And once again, we know anything divided by 1 is just itself, so x is equal to negative 2 plus or minus 2I square roots of 3. Okay, so now keep in mind this is 2 answers here. We have 2 answers here, 2 roots, and then we also, in the very beginning of the problem, if we scroll clear back up here, got x is equal to 4. So we had x is equal to 4, and then we had x is equal to 2 plus and minus 2I square roots of 3. So notice we have 3 answers here total, which would make sense because we started with a cubic equation, and we know cubic equations better have 3 solutions. We found the 3 solutions, and we were done. All right, let's continue. Another one, x cubed plus 1. Let's just factor this one, and then you guys hopefully know now how to solve using the quadratic formula. I'll just practice factoring from here on out. So we know that we can use the difference of sum or difference of 2 perfect cubes trick if we have 2 perfect cubes. Now we have 2 terms and they're both perfect cubes, so that's why we're going to use this trick. So for our front term, we'll take the cube root of x cubed, we'll take the cube root of 1, and then we know that our front term will be, well, that cancels out with that, so we get x, our front term is x, the cube root of 1 is just 1. So this is our front, this is our back. So then we'll go ahead and fill in our little thing. We put parentheses, we put our front term x, we put our back term 1, then our sign is always what we started with, so plus. Then we'll fill in the rest and sing our song. The front with the front, so that's x squared. Then we'll do the front with the back, so 1x, or just 1 times x, which is x. And then we'll do the back with the back. 1 times 1 is 1. And we'll close our parentheses and then go in and fill in our signs. If this was positive, if this was plus, then this must be negative. And then this end one's always plus. So remember this sign and this sign, you know how to get this sign first, and this sign will always be the opposite. So now we've factored this, we can set each of those factors equal to 0 and solve. I messed that up. So my eraser was huge and messed up. So we had x plus 1 times x squared minus x, and then plus 1. So we'll set each of those equal to 0 and solve for x. So once again here, x plus 1 is equal to 0. If we solve for x, it'd be easy. This, we've got to use the quadratic formula once we set it equal to 0. Let's practice another one. So looking at this, once again, we have the difference of 2 perfect cubes, because this happens to be a perfect cube and this does too. So to figure out what it is, what your front term is, take the cube root of 27x cubed, and we can split it up individually. The cube root of simply 27 is 3, and then the cube root of x cubed is just x. So our front term in this one's 3x. Then we take the cube root of 8, which is 2, and so our back term is 2. So then we do our little parentheses, we do 3x, and we write our 2, then we check our sign in the beginning is what our sign's going to be in here, and then we'll go in and do our song. So the front with the front, so 3x times 3x is 9x squared, and then the front with the back, so that will be 3x times 2, which is 6x. Then the back with the back, which is 2 times 2, which is 4. Now let's fill in our signs. If this was negative, this must be positive, and this one on the end is always positive. And now we'll set each of those equal to 0 and solve. So once again, setting this equal to 0, 3x minus 2 is equal to 0. Solve for x. So we get 3x is equal to 2, divide 3. So x is equal to 2/3. That's one of our answers. And then for this one, we'd have to go through and use the quadratic formula. Or if it factors further, we could use factoring, solving by factoring. But remember, the quadratic formula always works. Now, once again, the reason we're using quadratic formula is because it's quadratic, because it's degree 2. Okay, so this one we had troubles with in class, and I tried to get you to put it in standard form, and it made it more confusing, and then it hit me, well, it's way easier to just leave it like this and continue and fix the standard form in the end. So I'm just going to use this as my front term, and this is my front term. We do need to do our little thing though. So we're going to take the cube root of -8, and that is -2. That's our front term. Then we take the cube root of u cubed, our back term here, and we get u. Okay, so now we'll go ahead and do this here. All right, so once again, our song, we have to just go through and fill it in. First of all, we do our parentheses. Now, a lot of people in class, I carried the negative through, and it made it really, really confusing, so don't do that. Remember, we just know this is the difference of two perfect cubes, and then we go in and we fill in the signs. Now, think about it. We've never carried the sign through in any of the other problems. We didn't do the cube root of -8 here, so we're not going to carry, we didn't carry the sign through here. We just did the cube root of +64, so we're not going to carry the sign through on this one, just like any other.
Anna Boyle, please come to the office. Anna Boyle, please come to the office.
All right, so once again, we'll just fill it in. So you do the front term, which is -2, the back term, which is u, and then this is where the sign comes in. So we're going to put in our minus, because if it started as a minus, it's going to be a minus. And then we'll keep filling this in. So you'll do the front with the front. So -2 times -2 is +4. And then the front with the back. So -2 times u is -2u. And then we're doing the back with the back, which is +u squared. We close our parentheses, and then we go through and fill this in. Okay, if this was minus, then this must be positive. So I'm going to fix this to positive. If this is, and then the end term's always positive. Okay, so we got to go through and write this now in standard form. All right, and this is like problem number, let's see, I think, well, so where on your paper it says 125 minus x cubed. This problem is similar to that one, so we'll go through this one. So once again, we have two terms, and they're both perfect cubes. So if we take the cube root of 64, we're going to get 4. There's our front term. We take the cube root of x cubed, then we get x. That's our back term. Now you don't carry the sign through. We don't carry the sign through because that's just the difference of two perfect cubes. So we have it before, we won't now, because we account for it in our little trick. So we put our parentheses, you put the front term 4, and then you put your back term x, and then the sign is the same, so we put minus, and then you do the front with the front, so that'll be 4 with 4 times 4, which is 16. So 4 with 4, which is 16. Then the front with the back, so x times 4 is 4x. And then the back with the back, so that is x squared. Now let's go through and fill in our signs carefully. If this was minus, this will be positive, and this will be positive. Okay, so now we'll write it in standard form. So this will be -x plus 4. It was a -x. This is a +4. So -x plus 4. And then we'll have x squared plus 4x plus 16. Okay, so hopefully that was helpful. And then you'll set each of those equal to 0 and solve for x. So hopefully we're not confused on that, I pray. And we're going to talk about it probably for a couple of minutes on Monday as well. Thank you.